This is Unit 8, Circles, Tangents, and Chords. Let's adjust the paper here. Okay, so we're going to start with some definitions. It says a tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. The point where a circle and a tangent intersect is the point of tangency. So in this diagram right here, line L, which is this line, is a tangent line. And then point P is the point of tangency. Because that is where the tangent line and the circle intersect. So there's some theorems at the bottom of the page that just say if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So you have the radius here and then the tangent line. So that means line L is perpendicular to AB, which would be the radius. And then the second one says, if a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. So if this is perpendicular to this, then line M is tangent to circle C. Next page. Example 1. It says segment ML and segment MN are tangents to circle O. Find the value of X. So in this, we can say, in this polygon, all of the angles would need to add to 360. So you have angle, the measure of angle L plus the measure of angle M plus the measure of angle N plus the measure of angle O need to equal 360. So if the radius is perpendicular to the tangent line, then this would form 90 degrees here and 90 degrees here. So it would be, we know that the measure of angle L, this is angle L, so I just said it's 90 degrees, so you have 90 plus X is M plus another 90. And then the measure of angle O is 117, so that all needs to equal 360. So then you have X, if you do this on the calculator, X plus 297 equals 360. So then when you subtract 297 from both sides, you get X equals 63. And it said find the value of X, so we're done. Example 2, it says ED is tangent to circle O. Find the value of X. So here we're going to say that the measure of angle D plus the measure of angle E plus the measure of angle F equals 180 degrees. So we have this right here is F. It's not labeled on the packet. So you can put it here. So, you know, all the angles inside a triangle add to 180 degrees. So you have the measure of angle D plus the measure of angle E plus the measure of angle F equals 180. So we have here measure of angle D. We know that this is going to be 90 because this is perpendicular to that. So you have 90 plus the measure of angle E is X plus F is 38 degrees, and that needs to equal 180. So you can do that on the calculator. You get X plus 128 equals 180 minus 128 from both sides. X equals 52. Now it says, is segment ML tangent to circle N at L? Explain. So basically what we need to decide is if ML is perpendicular to LN, which would make this would have to become a 90-degree angle for that to be true. So then when we can check that with your A squared plus B squared equals C squared, where C is the hypotenuse. So we need to do this. So you would have, basically we can call A, so is NL squared plus LM squared equal to, we want the number equal to NM squared. See, this is the hypotenuse because it's across from the right angle. So when you plug the numbers in, it's going to basically be 7 squared plus 24 squared equals 25 squared. So you have to do this on your calculator. 7 squared is 49 plus 576 for 24 squared. And then 25 squared is 675. When you add these together, you get 675. So it does work. And so from that, we can say angle L is a right angle. Therefore, ML is perpendicular, that's a symbol for perpendicular, to NL. So then the final answer is yes, ML is tangent to circle, it's a symbol for circle, N at L. Next page. Okay, so a chord is a segment whose endpoints lie on the circle. So here's endpoint 1 is on the circle, endpoint 2 is on the circle. So you can say AB, segment AB is a chord. If two segments are tangent to a circle from the same external point, then the segments are congruent. So in this drawing here, AB would be congruent to AC. Example 4. Segment GH and segment HK are tangents to circle F. Find GH and HK. Okay, so we just said if two segments are tangent to a circle from the same external point, okay, then the segments are congruent. So we could say that segment GH is congruent to segment HK, meaning the measure of segment GH is going to equal the measure of segment HK. So now if we look here, GH is 4 plus 2A, and that's going to equal HK, which is 5A minus 32. So now we would solve that. So if we minus 2A, so you have 4 equals 3A minus 32. Subtract 32 from both sides. So then you're going to get Sorry, I was looking because I did this wrong. You have to add 32 to both sides. Sorry. So add 32, because this is minus 32, so you're going to add 32 to both sides. So then you get 36 equals 3a, divide by 3, divide by 3. So we're going to get a equals 12. But it said to find GH and HK, so now we have to plug A in back in. So you have for GH, it says that's equal to 4 plus 2A, and we said A is 12, so we're going to substitute 12 in for A. So then you get 4 plus 24, so GH equals 28. Now, they're supposed to be congruent, so HK should equal 28 as well. So to check your answer, you can also do the math out. So HK equals 5A minus 32. We know it's 5 times 12 minus 32, which is going to be 60 minus 32. So HK equals 28. And they should be the same. So you know you got it right. Next page. Example 5. Circle O is inscribed in triangle ABC. Find the perimeter of triangle ABC. Okay, so this side AD is congruent to AF. So if that's 10, this is going to be 10. So you need to label. So then over here, FC is 8. So CE is 8 as well. And then you have 15. I'm going to put 2 hash marks on that one. And I'll put 3. They're different. 15 and 15. So when you do the perimeter, you have to add all those up. So you're going to do 10 plus 10 plus 8 plus another 8 plus 15 plus 15. So when you get that, it's going to be perimeter equals, when you add that up on the calculator, you get 66 centimeters. Example 6. Circle O is inscribed in triangle PQR. Triangle PQR has a perimeter of 88 centimeters. Find QY. So this is going to be congruent to that. We have 15 here, so this is 15. So we have 17 is here. Let's put 2 hash marks here, so this is 17. So we know that 88 is the perimeter, so we're going to put 88 equals. We have 15 plus 15 plus 17 plus 17 plus QY plus QX. So when you do that on the calculator, you get 88 equals, you add these numbers up, you're going to get 64 plus QY plus QX, because we don't have either of those. So you're going to subtract the 64. You get 24 equals QY plus QX. They have to be exactly the same. So if you divide this by 2, because they're congruent, so they have to be the same. So really, if you do that, QY is going to equal 12, and QX is going to equal 12. Again, I just divided the 24 by 2. So you'd have 12 and 12. So the answer asks for just QY though. So actually I'm going to take my box away from this. So QY equals 12 is your final answer. Sorry, that got a little messy. Okay, more theorems on circles. Congruent central angles have congruent chords. Congruent chords have congruent arcs. Congruent arcs have congruent central angles. Chords equidistant from the center are congruent, and congruent chords are equidistant from the center. Next page. Example 7. What is the value of A in the diagram below? So, what we need to do is you have PR, because you're given PQ here is 12.5. So, PR is going to be the same length as A. So, if we're given the 12.5 here, and that's congruent to this part, QR, so PQ is congruent to QR. It's marked there. So we can say that PR is 12.5 plus 12.5, right? Because you have 12.5 for this part and 12.5 for this part. So PR equals 25. A, which is this right here, is the same as PR. So we can say A equals PR. So A equals 25. And then it says the reason that we know that they're the same is because chords that are equidistant from the center, so they're the same distance away from the center, so you would know that those are congruent chords. In a circle, a diameter that is perpendicular to a chord bisects the chord and its arcs. So example 8. Okay, just turned on another light to try to make it a little lighter on the paper. Okay, so it says example 8, what is the value of R in the diagram below, round to the nearest tenth? So R is here. And we know that Kn is 3 centimeters, so we need Ln. So we can see that Ln is half of Lm, which is 14. So Ln equals 1/2 of Lm. So Ln equals 1/2 of 14. So Ln equals 7. So we know that. But now we need to find R. So R is this side of this triangle right here. And Ln is the bottom, which is 7. And this is 3. So knowing that, and knowing that this is a right angle, we can use our A squared plus B squared equals C squared, where C squared is the hypotenuse, which would be across from the right angle. So for this, we can say 3 squared plus 7 squared equals R squared. So you have 9 plus 49 equals R squared. You can do that on your calculator. And then we add those, we get 58 equals R squared. So then you would take the square root of each of those. So you would get R equals the square root of 58, which when you do that on the calculator, it says round to the nearest tenth. So you get R is about 7.6. And that's the lesson for today. Have a good day.